One of the most classic and decorative joinery techniques in woodworking is the dovetail joint, reflecting craftsmanship and providing a strong mechanical bond between two pieces of wood. Making them by hand can be both rewarding and frustrating. But can we make them with precision in Blender? Of course we can. And in this video, I'll show you how. So I'm going to show you two methods today on how to create a drawer box like this accurately. One being a little more time consuming and involved, but also the most accurate. And the other one is a little quicker and easier, but just as accurate, and both are common practice in carpentry. So let's start with the advanced one, which is the formula method. So I'm going to get rid of my finished drawer here and bring in a new piece. And I'm going to use booleans for all of this. So I got to make some cutter objects. So I'm going to select my piece here and tap into edit mode. And I have a mirror modifier on here. That's why it ends right here. So I'm going to select these two faces here and Shift D to duplicate them. P to separate that selection and go back into object mode. And now in my collection here, I have a new object, which I'm going to bring forward a little. And that is what I'm going to use as a cutter object. I'm going to get rid of the mirror modifier on here. Won't be needing that. I'm also going to go into solid view for the time being. Now, the first thing we need to do is carry the thickness of our board into the length of the board 3 times. So if we look at our dimensions here, the thickness of the board is 16 millimeters. So I'm going to use the outset tool for it. Tab into edit mode. Select my face here at the end. Actually, I'm going to go into edge mode quickly and I'm going to clear the seams here. So in face mode, I to inset, O to outset, equal for the advanced mode 16 times 3. Then, of course, I need the simple thickness, because when the other drawer piece comes in here, that is also 16 millimeter thick. So again, I to inset 16, and there is my simple thickness. And now I need to do this one more time for half the thickness. So I8, enter. And then I can get rid of that face. And I can also get rid of the vertices at the end here now. So X, delete those vertices. Go into front view. And now we need to establish 3 things. We need the number of dovetails. We need the number of pins. And we need to know how to divide our piece. So let's start with the number of dovetails, and that's where the formula comes in. So we need to take the width of our board, which is, if we tab into object mode, 120 millimeters. So we need to take 120. I already apologize for my glorious writing here. And we need to divide that now by 3 times half the thickness. So 3 times half T for thickness. So that's right now would be 16. So that's 8 times 3 is 24. 120 divided by 24 makes 5. So we have 5 dovetails. The next piece of information we need is the number of pins, which is pretty simple because there's always one more pin than dovetails. So with 5 dovetails, we have 6 pins. And lastly, we need to know how many parts do we have to divide our board here. Well, every pin is 1 part and every dovetail is 2 parts. They're considered split down the middle. So with 5 dovetails, we have 10 parts, plus the 6 from the pins makes 16 parts. So that's how we have to divide our board here. So I'm going to go back into edit mode on my cutter object here, Control R to make a loop cut, and I'm going to scroll my mouse wheel up till up here I see 15. And now we have 16 parts on our cutter object. And from those, we can now establish the angle of our dovetails. We should do that in front mode because we can use the knife tool for it. So K to activate the knife tool. We know the first part on the bottom here is a pin. So the second edge here, that is the center of our dovetail. So we're going to grab the vertex on the very back here. And then we look at this vertex here, and when it turns gray, when I pull this through right there, that means I'm snapping to that vertex and continuing the line straight through. And that's where I want to cut. I'm going to do that same thing in the other direction, right there. And now this is our dovetail, precisely calculated. Now we just need to make that 4 more times. So again, knife tool, K, grab the back here, and when it's gray, cut right through. And I'm just going to do that quickly for all of them. And there we go. Now, if this method seems a little cumbersome to you, it is. But the reality is, it's the same in the workshop. This method is just as cumbersome when you do it on a piece of wood. That's where the second method comes in a little bit. So now I can start deleting stuff I don't need. And to get the dovetails on my board, I actually want to keep the pins here and cut them out of the other board. So I'm going to get rid of all the vertices on the back. I don't need those anymore. And then I'm going to delete all the vertices within my dovetails. So all of these, X, delete those vertices. And then I can clean my pins up a little so the resulting topology is a little cleaner. Control X to dissolve those. So there are my pins that I now want to cut out of my board. So I'm going to add a solidify modifier. I'm going to make sure it's thicker than my board. And I'm actually going to apply the solidify modifier. And then I can GY move it in here. Shift select my board. Control minus on the number pad. And there is my cutout if I switch over to exact. And now you can see why I applied the solidify modifier, because now I can go back to my cutter object, go into face select, and select all the outside faces here. Because booleans are always a little tricky in Blender. Alt E, extrude individual faces outwards. And there are my dovetails. And because of the mirror modifier, they appear on the other side too. Just turn on cavity here so it looks a little nicer. So that is step 1. Now we need to transfer that onto the other board. So I'm going to bring my front in here. And because those dovetails are precisely calculated to the dimensions of my board, they will not change anymore. And I can apply my Boolean. So Control A to apply it. And then on my other board, I'm just going to add a Boolean modifier. I'm not going to use the bool tool for this because I don't want this board to be displayed as a wire or bounds. So I'm just going to add the Boolean modifier by hand. Select my side. And technically it is already working, but you can see we have the same problem again that we had before. If we ignore my annotations here, in that we still have those thin faces. So I'm going to go back to my side here, go into edit mode and select all the outside faces here. And just temporarily Alt E extrude the individual faces, bring them outward a little. And then we can see we have our pins on the other board here. So now I can apply my Boolean modifier on the front here, Control A, and then go back to my side one more time, deselect this side, GX, snap them back to the other vertices, select this side, GY, snap them there, A to select everything, M, merge by distance. And now, if I go into rendered view, I have perfect, precise dovetails on my pieces with this formula here. So the The most important part is always establishing how many dovetails you want to have. And that's done by taking the width of your board, dividing it 3 times by half the thickness. And that way you have established how many dovetails your board will have. So there is method number 1, which is the most accurate one. But because this is so cumbersome, and again, even in the workshop, it is like that, there is another more commonly used method, and that's using a ratio. So here's the thing about dovetails. They're not just structural, they're also decorative. And you can vary the size of those depending on how much structural strength you need. So if you need more strength in your connection, it is advisable to use more and smaller dovetails, where if it's decorative for, let's say, a little jewelry box or something, where there is no strain on the connections, you can just choose to have bigger and less dovetails on your connection, and that's perfectly fine. So that's also another reason why the ratio method is so common. So for the ratio method, you can actually buy dovetail gauges, which you can then use to draw the ratio onto your piece of wood. And of course, we can recreate them in Blender. And I find it easier to work on the head of the board rather than here on the side. So I'm going to switch my piece here and get the front in. And then I'm going to create my dovetail gauge first. Let's go with a 1:7 ratio. Dovetail gauges range from anywhere, usually 1:5 to up to 1:10. The most commonly used ratios are 1:6 for softwood and 1:7 for hardwood. So let's go with a 1:7. So I'm going to switch to solid view here and Shift A, bring in a plane. And I'm going to call this 1:7 ratio. So that plane, I'm going to make 70 millimeters on the x-axis and 20 millimeters on the y-axis. Because the 1:7 ratio, of course, means that for 70 millimeters of length, we rise 10 millimeters. So I'm going to apply my scale, tab into edit mode, and I'm going to take these 2 vertices on one end here, M to merge at center. And there's pretty much my gauge already, with a perfect 1:7 ratio in both directions. Again, dovetails are considered to be split down the middle. Now you would never have a dovetail that is this pointy at one end. So I'm just going to take my knife tool and cut it somewhere around here. X to delete that vertex at the end here. I'm actually going to bring my object origin to these 2 vertices here. And then I'm going to rotate it on the x-axis by 90 degrees. And now I'm in the right view. Actually, if I bring them over here, I gotta flip them over on the y-axis by 180 degrees. Because when I have my side piece coming in from this side here, I want to have the dovetail the right way around and not this way, because otherwise the pieces just slide apart. So R, Y, 180, and there we go. And I want to make sure that my dovetail is right in the middle of my board here. And then I can place it wherever I want. And this is now where I have a lot of freedom in sizing it. So I could place it all the way here and have a smaller dovetail, or I could pull it back and have a bigger dovetail, and the ratio stays exactly the same. And if I want to have it even bigger, I can bring my gauge over all the way here, select my 2 vertices, GG to edge slide. And if I now press C, I can slide past the origin point and make it even bigger. So that's where the freedom comes in without losing the precision of the perfect ratio. So I'm going to keep it the way it is though, for the sake of this tutorial. I'm just going to place it something like this, and I'm going to apply my rotation, and you'll see in a second why. So I'm going to bring it out of here, and I'm going to add a solidify modifier, and I'm going to give it a thickness of 19 millimeters. And that way, when we cut in our 16 millimeters, we're already proud of the board, and that way we have less of those Boolean issues. So I'm going to bring it in, GY, snap it to there, and back out by 3 extra millimeters. So GY minus 3. And now I just need to spread it out. And for that, I'm going to use an array modifier, and that's why I applied my rotation so that the Z rotation is the correct one. So I'm going to add an array modifier, and I'm going to go with a constant offset on the Z axis. And now I can spread them out. And I want to have 2 in that direction. And this is where I'm going to look out that I have this edge and these edges in between roughly the same. And that actually looks pretty good. I could go by the grid. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we go. That's actually pretty good. And of course we need the same ones on the other side. So I'm going to shift my array modifier, and I'm going to switch the 23 millimeters to minus 23. And there we go. And still I have the freedom to move them out if I want to have smaller dovetails. And it doesn't change anything about the ratio at all. There's still precisely 1:7 dovetails. Actually, we can move them out a little bit. So that looks good. We have them in the 16 millimeter that we need. Shift select the front, Control minus, and of course it's funky again. So I'm going to bring the Boolean up to the top. Let's see, exact. Yikes. Self-intersect. There we go. Booleans can be a pain in Blender. You always have to play with all the options here to see if something works. But yeah, there's our dovetails cut into our front. Now we just need to cut them into our side again. And this time I'm actually going to make a copy of my front here. Shift D, right click to cancel the movement. And I'm going to get rid of the mirror modifier, and I'm going to apply the Boolean modifier. Control A. Tab into edit mode, and I'm just going to select these outside faces here on my pins. And I'm going to press Y to separate them. GY to bring them out a little bit. Control I, X, delete the vertices. So then I can A to select everything. I'm going to go into edge mode quickly and clear all the seams. Clear seams. And then I'm going to extrude them to something like that. Go into object mode, bring it into my side piece here. And then I'm also going to select all the outside faces again. This is pretty similar to what we did on the other one, just that we don't do it on the side actually, but on a new cutter object. Alt-E, extrude individual faces a little. And there we go. Shift select the side, Control minus. And if I drag that up now, we can see we have our dovetails here with a bunch of holes. Let's see. Exact. There we go. Exact solved it. Again, you have to play around with Booleans all the time. But now if we look at it in render view, we can see we have perfectly ratioed dovetails in a much simpler way without all the math. And if you've watched my channel before, you know my math doesn't always math. So I prefer this method a lot. It's a lot faster too. And now from here, we could of course apply our Boolean modifiers again and copy our pieces around, create a draw bottom, and then get something like this. And when you create the draw bottom, make sure that it's sitting within the dovetail, because that's where you would place it in real life too. Now, of course, you could say that creating a dovetail gauge every time you need dovetails is just as cumbersome as calculating them. But the thing is, you can just create the dovetail gauge once and then save it to your asset browser. If you look at my asset browser, for example, I have 4 saved to it, from 1 to 5 all the way to 1 to 8. And whenever I need them, I can just drop them in my scene and create my cutter objects from there. And that makes the whole process a lot faster and easier. So there you go. There's 2 methods of creating precise dovetails in Blender. I hope you found this helpful in any way. If you did, leave a like and subscribe, you know the deal. Make sure to grab your copy of Knobs and Pulls. Thank you so much for watching, and I'll see you next time.